Okay, we are going to go through a little how-to of solving systems of equations using the process called elimination. So just like with substitution, there's really just some steps to follow, so there's a process to this. I think there's kind of like 4 steps really. So we're going to combine the equations through addition or subtraction so that one variable has a coefficient of 0. This is called elimination. Yeah, so it's going to be a new thing. Once we do that, though, we're going to have one equation with one variable, and with that, we'll determine the value of that variable that makes the equation true. Once we have that value, we'll go back and substitute it into the appropriate variable or for the appropriate variable in either one of the original equations. So it doesn't matter which one we choose, but I highly recommend you choose one of the original equations. And then finally, we'll determine the value of the remaining variable that makes that equation true. So I'm sure you're thinking, like, what are you talking about? All right. So, especially the first step. So for now, just trust me. It's going to work out. It's pretty slick. And if you want to know, like, well, how does this work? Why does this work, Mr. Myers? I'd recommend just looking at the graphs of the original equations, like in Desmos. You could type them in, and then you don't even have to add them together to eliminate. You can just add them together, and then you can look at the resulting graph of that equation, and you'll probably see it. Or you can talk to me about it, and I can show you, or we can just talk about it. But it's pretty cool. So let's just get back down to the process, I guess, then. So I said the first step is that we're going to combine the equations through addition or subtraction. So for this first example, I chose some where it's going to work out pretty nice from the get-go. So if I add these equations down, so I add them together, I combine them through addition, I have negative 2x plus a positive 2x. That gives me a 0x. And then I'll have a positive 3y plus a negative y. That gives me a positive 2y. And then finally, on the other side of my equal sign, I'll have a 4 plus a negative 8, which gives me a negative 4. So I will kind of stop and mention, all of my like terms were lined up vertically, right? I had the x over the x's, the y's over the y's, and the constants over the constants, and that's important for this process. So, well, 0 times x is 0. So the left side of my equation really could have been written as 0 plus 2y. Further, 0 plus any number is just that number. So I really didn't need to write the 0, I could have just written the 2y. And that's why it's called the elimination step. So by combining our equations so that the coefficient of x was 0, we've essentially eliminated the x's from our equations. So we have this new resulting equation. 2y equals negative 4, and we need to know the value of y that makes that true. So dividing both sides by 2, we would get negative 4 divided by 2, which is a negative 2. So that's our value for y. And now we're at the third step. So the third step is to take this determined value and substitute it in for a y in either one of the original equations, and it doesn't matter which one. So I'm going to choose to use the bottom equation. So 2x minus a negative 2 equals negative 8. So there's my substitution step. And then this final step, right, is just to determine the value of x that makes this equation true. So I will choose to simplify my my left-hand side of the equation. Well, made a mistake there, right? So minus negative 2 is actually a positive 2, not a 4. Then I'll subtract 2 from both sides. That gives me that 2x must equal a negative 10. And if 2x is equal to negative 10, then x must be whatever negative 10 divided by 2 is, which in this case is a negative 5. So x equals negative 5 and y equals negative 2. That's our solution. Right? Our solution to this system of equations is negative 5 comma negative 2. Well, I hope this helps at least show you the process of elimination. And remember, math is cool, and so are you.